1-7, last section of chapter 1, which means your test is coming soon. Today's vocabulary is actually pretty straightforward, but is hugely important. Will get used the rest of the year, so you might want to make sure that you understand these. Perpendicular lines, I'm guessing most of you. This is one of them you probably can define, right? Two lines that do what? Yes? Yeah, intersected. I mean, you're not going to get a whole lot better than that. So apparently the definition's not in there. Somehow it got moved over there or something. Interesting. Anyways, there it is. I have no idea why it was way over there. Intersecting lines that form four. Right, four. How does it form four? How does it form four right angles? How's that work? Let's see if this other one, yeah, that one's still there. So why that other one got moved, I have no idea. Right now, do we have any right angles in that picture? Based on the drawing? No. So how are they getting four, though? Well, 1, 2, 3, 4. And it should make sense that if you add up all those, it gets to 360, because you would go all the way around, right? Okay. So intersecting lines are for right angles, and the symbol for perpendicular. Again, we're mathematicians. Come on. You think we're going to write that every time? Not a chance. All right. Let's face it, we don't even want to write the word plane every time, but we kind of have to. All right, so what's the symbol? Nope. Yeah, it's an upside down something.
Upside down T.
Well, if it's upside down T, I mean, it's the same as just a regular T, is it? Oh, capital T, okay. It is correct. That's perpendicular. That's the symbol that will be used. And obviously they make it an upside down capital T because otherwise it would look like a T. So there you go. Perpendicular. No big deal. That's not too hard, right? But again, do not make any assumptions. If you don't have some kind of reason to know those are right angles, please do not assume that they are. Okay. Adjacent angles. Ooh, somebody thinks they know. Yes? Not quite. Yeah, kind of next to each other really is what's had fun. Oh, hey, that one's actually where it's supposed to be. Angles in the same plane, I think that's pretty much given at this point, but they put it in there, that have a common endpoint and common sides. Now, you can write all that in, but really, do I have a picture in there for you? Not yet. Those are considered adjacent, and maybe I'll color them for you a little bit. Basically, what some people say is they're right next to each other, or they bump up against each other, or some say they share that ray, that's kind of in the middle. Again, I'm not necessarily going to make you just give me this strict definition, but if I show you some adjacent angles, I hope that you can, oh, here's adjacent angles, because that way when I say it, you can look at the right place. Okay. For example, I hope you realize that this angle right here and that angle right there, well, they're still kind of next to each other, but do they count as adjacent? No, because they're not sharing that endpoint or a side. All right? So do you understand the difference between the two green ones I just drew and the red and green one that are over there? I hope that you do. Okay. And so you might want to get that picture in there. It might be helpful. And seeing we're going to fill in some blanks over there, you might want to use the same letters. That might be helpful. So to fill in those blanks, is it okay to say angle X and angle X are adjacent angles? Is that okay here? No, that goes back to what we said the other day. There's just too many angle X's in there. You can't do that. But you can go to, let's see, are they in there? Yeah, all right. ZXY is one of them. Do you have to label it that way? No. You could say YXZ and WXZ. Okay. Or sometimes you might have numbers in there, remember, so maybe that's angle 1 and angle 2, and you can just say it that way, but that's not what we have in this one. You could always add that in if you want, angle 1 and angle 2, that'll save you some time. It's up to you. Okay. What is the common side? Now be careful how you say this. Yes, Ms. Rockwell. Is that correct? Ray XZ. For one, is it a ray? And then did she write it in the correct order? Yes, she did. XZ. Remember, you always want that kind of pointing to the right. And then you got to make sure, well, which way does it continue? Well, it continues towards Z. It keeps on going. Common vertex, I think that one's pretty straightforward, right? We already kind of talked about that, right? And again, angle X in this case, there's 3 of them. And so it's not good enough to say, oh, angle X and angle X. So far we've got what? Perpendicular lines, and we have adjacent angles. Would you say when we did those perpendicular lines, did we form some adjacent angles when we did that? Yeah, we did, didn't we? In fact, we formed 4 of them that all happen to be 90 degrees, okay? So that's a big one right there. This one I think we were kind of told already. This one's huge. Know this one, it will not go away. Same with the next one. You will be using this 6 months from now. Okay? Vertical angles. Now, let's just talk about it. Don't start writing right away. Let's just get a picture in there and then write down what you think it is. So non-adjacent, well, wait a minute, we just learned what adjacent was. This is non-adjacent angles formed by 2 intersecting lines. They are also congruent angles. So right now, I don't even have, it is in there, all right. Do I now have 2 intersecting lines? Yes, why don't we start with the picture, then I'll have you go back and do the definition. So go ahead, get yourself a little picture with those letters, might be helpful, you never know. But they have to be non-adjacent. And what I'll probably do just to make this easier for us, I'll just have us number those angles that just got formed, all right? Just to speed things up. So angle 1, 2, 3, and 4. Because again, angle E, just saying that's not enough. You're not necessarily going to know which one to look at. But now if I say angle 1, you should know which one to look at. How about angles 1 and 2? Are they adjacent based on the definition we just learned? Angles 1 and 2. Yeah, they are. How about 2 and 3? Are they adjacent? Okay, so we have to look for non-adjacent, because that's what it says right here. Well, are there any angles here that are non-adjacent? Yeah. 1 and 3. Now, how are they not adjacent? They share a vertex, but they don't share a side. You see the difference there? They share a vertex, but not a side. So I would say, yes, 1 and 3 are good examples of vertical angles here. So how about 2 and 4 then? Do those count too? Yeah, those also count. So that is basically what the vertical angles is. And what I tell people is when you have intersecting lines, don't they normally kind of form a V? At least if you just look up here. That's a good way to remember vertical angles, all right, is with that V. And now what it says here is that vertical angles, so you told me that 1 and 3 were vertical angles, right? Well, guess what? Those, according to this, are congruent. And then you also told me that 2 and 4 were vertical, so those will be the same. What that means is if this one up here was 60 degrees, and I have 2 lines intersecting like this, what's angle 3 got to be? 60 degrees. Now we're going to talk about something in a second. This one has to be 120, and we'll talk about that, why that is in a second. But if the angle 4 is 120, angle 2 also has to be 120, okay? So that's what congruent means. If you ever get that, make sure that you know. If it's vertical lines, so 2 lines intersecting, again, this will hold true for the rest of the year and even past that. Any questions about that? No? All right, so that's a big one. Might want to star that or something in your notes, whatever it is you're going to do. If you got a highlighter, maybe highlight that one. And so I'll give you a second to put in some kind of definition if you want, whatever is going to make sense to you. I mean, you can copy that down if you want, but it does not have to be exactly that. Everybody got something down? Give you a second. Everybody's good? All right. Linear pair. Linear is an adjective in this case. What's its root? Line, very good. Again, a lot of people like to say ear. Isn't that the root? It is a line. So, linear pair. Well, let's see what it says. Ooh, back to adjacent angles. Well, there's another non, all these prefixes. Non-common sides are opposite rays. Sounds complicated. So we have some adjacent angles. In my picture right here, I have a blue line, right? So do I have any adjacent angles in my picture right now? No, I don't. And hopefully none of it got moved. I'm pretty sure it's right in there in the middle somewhere. There we go. Now do I have some adjacent angles if I throw that ray in there? Ray QR? Yeah, so why don't you get that picture in your notes? And then we'll talk about a linear pair. And maybe we'll number them again just to kind of make life a little easier on ourselves. 1 and 2, right? So our adjacent angles are 1 and 2, right? Now it says whose non-common side. Well, if you want to find a non-common side, sometimes it's helpful to find which one is common, because then the non-common ones are the other ones. So the common side, I think we all realize, is right there. They share ray QR, correct? So the ones they don't share, or the rays they don't share, are QT and QS. So they're saying the non-common sides are supposed to be opposite rays. Are those opposite rays right there? QT and QS. So in other words, QT and QS basically come together to form a line. Oh, so basically it's a pair of angles that form a line. Right? That's basically what it's saying. So we actually know more about, are 1 and 2 going to be congruent? Could they be? They could be, but do we know for sure? But we do know one thing for sure. We know that. Measure of angle 1 plus the measure of angle 2, you should know that. Because if it's a linear pair, what do those have to add up to be? 180. Because that's what opposite rays, or again, we call that a straight angle, that's what that adds up to be. So kind of like that last example, what was it? We had a 60 in there, and I told you it kind of had to be 120, and that's why I said that in the last example when we had those vertical angles. Because do you see in vertical angles you actually also have linear pairs? So there's your vertical angle picture, right? How do we number them? Something like that, right? R1 and 2. If I just look at that and cover up the rest of it, if I cover up with 3 and 4, aren't 1 and 2 a linear pair? Well, how about 1 and 4? 2 and 3? Yeah, they're all linear pairs. But how about 1 and 3? No, 1 and 3 are not. They are, what are they called again? They are non-adjacent vertical angles, yep. And 2 and 4 are also vertical, okay? So watch out for that. You're going to see these pictures a lot. Know that if they are adjacent like that, they are a linear pair. And if they're non-adjacent, like 1 and 3 and 2 and 4 in this last picture, then they're what are called vertical. And what do we know about vertical? They must be congruent. Okay? So keep that in mind. Okay, any questions so far? So I'd say those last two are huge. So maybe star this one as well. It's not that the other ones are not important, it's just these last two are very important, linear pair and vertical angles. Well, let's try and use some of this. Determine the value of x and the measure of KIH. Okay? Well, it tells me over there that GIJ is 9x minus 4. All right, well, we better put that in there. I gave you this picture, right? Okay, good. 9x minus 4. And JIH is 4x minus 11. They want x and KIH. Huh. Well, then we have to decide. We have two lines that are coming together at I. Do we know if I is the midpoint or anything like that? Does it say that in this problem? It doesn't say that. It might be, but it kind of looks like it, but we better not assume that. But we're talking about angles anyway, so that's probably not all that important, right? Are those two angles going to be the same? Do we know that? Well, they could be, but we have no reason for knowing that they would be. But I do know that if I take those two together, and maybe I'll just, again, 1 and 2. If I put angles 1 and 2 together, that's a linear pair, right? I know that those two, when added together, have to be 180. So once again, I know the total. So sometimes you know the total, sometimes they're the same, it all depends. So we know that those added together have to be 180. All right, let's do it then. 9x minus 4 plus 4x minus 11 better equal 180 degrees. Now, again, keep in mind that this 9x and that 4x, they're already on the same side of the equation, so just go ahead and add them together. That's 13x's, I believe. And this negative 4 and that negative 11 are already on the same side of the equation, so do that. But here's where people mess up. If you struggle with negatives, think of money. Negative 4 means you owe me $4. And then negative 11 means you owe me $11 more. So you owe me $15. See how easy that is? Equals. Very neat. Again, you could divide by 13 right now. It's just not a very good choice. You know, you could divide by what's a good number? 201, if you felt like it. It's just not a good idea. I think adding 15 is probably the most logical thing to do next. Again, I could add, 1002, but not a very good idea. Now that 195 over there might not seem very nice. Well, let's find out. Because now that we've gotten this far, we've done all that adding and subtracting again, so we're going to take ahead and we're going to go ahead and divide by this 13 here. Hopefully that comes out nice. Yeah, 15. Yeah, I'm hoping you knew there was a 5 at the end, because 3 times 5 would have gotten you the 5 on the end there. At least you knew there was a 5 there. Hopefully you had that figured out. Did we even need that? Oh, yep, value of x. Okay. Now the question is KIH. Well, that's down here where I just put that dot, right? That's KIH. I don't even know anything about that angle. Yeah. Yeah, exactly. It's vertical. Basically, I'll number that number 3 then maybe, right? 1 and 3 are vertical in this problem. So whatever 1 is, 3 better be the same. So I can just go ahead and substitute 15 right in there. So it's 9 times 15, remember, not 915. Okay, 9 times 15, that's a little bit bigger, okay, but I think we can probably handle that. 9 times 15, yeah. 135 is correct. Minus 4. 131. Degrees, right? So 131 degrees. That's pretty good. Now, how would you go about checking this one? Yeah. You could do that, then it would be 360 total. Or what we could do is just kind of put that 15 right in there. And we know those two are supposed to be a linear pair, right? So they better add to 180. You could do it that way too. Any of those ways is fine. And we do that, and we're good. It checks out. Okay? So 131 for that angle, and x is 15. Okay? Any questions like that? Now, the only other thing that might happen to you is I might throw the... Now, this problem's done. Is everybody good with that? I'm just going to show you something else that might happen. That worked really well. Okay, the only other thing that I can really do to you is give you something here. So maybe it's still 9x minus 4, and then give you something down here, 8x plus 6 or something. Oh, you're going to add those two together to be 180 like we did in this last problem? No. Is it possible that actually is what happens? It's possible, but it's highly unlikely, right? They would have to be perpendicular lines for that to work. Okay? But we do know that, again, what do we number those, 1 and 3 or something like that for angles? We do know that those two, they're still vertical, right? So they better be the same. And again, another word for same is equal. So you'd set them equal to each other, solve for x, and go from there. All right. So you see how it's very similar to a lot of the stuff we've done through this chapter. You just have to figure out, do I know the total? Are they the same? What's the deal? All right. Any questions? I think we'll probably stop after these two. I don't know if we'll do that last one. Maybe we will, just for some fun. We'll see. 2A. Oh, that is? Oh, there you go. We're not going to do the last one then because it's not even on your notes anymore. Two angles with the sum of 180 degrees are called... Okay, you could say it's possible that they'd be a linear pair, but this is just saying if I just grab two angles out of anywhere. Not necessarily, but I like that connection that you made. Again, I can just pick two angles out of anywhere, and if they add to 180, they are supplementary. They are the supplement of each other. And again, two angles just out of anywhere that add up to 90 are called... Now, they could be adjacent, but that's not saying that here, right? They could be right next to each other, but we don't know, right? And that's not saying each of them's 45 either, or each of them's 90 in the other one, right? For example, for this complementary, it could be 20 and 70 for all we know, but they do add together to be 90, so that is complementary. Okay. And just so that you understand the verbiage, for example, do you agree if I had a 120-degree angle and a 60-degree angle? We seem to be using that one a lot. Those two angles are supplementary, correct? Or sometimes it's said that 60 is the supplement of 120, or vice versa. Okay? And same thing down here, if you've got, let's use 30 and 60, 30 and 60, they are complementary, or 60 is the complement of 30. Do you understand the verbiage there, that they could use that way? Okay. Any questions?